Hi everyone. Today we will be focusing on trig equations again, but this time we're going to be solving complex trig equations, not simple ones, and we'll show you what that means. But you can see it here in the objective. There'll be multiple angle trig identities, so we'll talk about what that means and use the same steps as yesterday's lesson. So when solving complex trig equations, that's when you have the variable inside the trig has a coefficient other than 1, like this example, cosine of 2x equals 0. So today we're just going to solve this one as we go through the steps and then talk about what to do whenever that happens. So the first step is the same, isolate the trig function, and it's already isolated. So the 2's inside of it, we can't get rid of it as it is. And so what we want to think is basically when does cosine of theta equal 0? So for what angle does cosine equal 0? So remember, I like to use this method. Equal x value is 0 at the top and at the bottom, so that's at pi over 2 and at 3 pi over 2. And so really, we're going to replace that theta with 2x. So we'll say 2x equals pi over 2 and 3 pi over 2. And we want to find the coefficient times the coterminal angles. So what that means is I'm just going to keep adding solutions. So if I start here and I go around 2 pi, I can add 5 pi over 2 to it. And then I can do the same thing here. I can go around 2 pi and add 7 pi over 2. And that gets me double the amount of solutions that I already had. So that's what that means. In this case, it would be 2 times because x equal the number in front of the x was 2. And then we divide by our coefficient for our final answer. So we'll divide everything by 2. And what that looks like is x will equal pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And that is our final set of answers for this problem. So you have to add the coterminal angles for the number of times as the coefficient. And so you just take your answer and just keep adding 2 pi to each one to get a coterminal angle for that one. And if it's 3x, you have to add it a couple times. 4x, you want to make it to be added 3 times, so you have 4 answers, etc. So let's do some more problems. This one, sine of 3x equals 1. And so the trig is already isolated. Where does sine equal 1? That is right there at 3 pi over 2. So we're going to say, theta equals 3 pi over 2. And so I'll just put the 3x equal to 3 pi over 2 there. And then I'm going to add, there should be 3 answers. So we have 3, there should be 3 answers. So 3 pi over 2, I need to go around 1 whole pi. So 2 plus 2 pi over 2 would be 4 pi over 2. 7 pi over 2 and 11 pi over 2. So I'm going to add 2 pi until I have 3 times as many solutions. And I added 2 pi or 4 pi over 2. So now I'll divide by the 3. So divide by 3, divide by 3. And what that looks like is x equals 3 pi over 6. So that's pi over 2. Oh my goodness, what am I doing again? Sometimes I make silly mistakes. This would have been pi over 2 just pi over 2 the whole time. If we were in class, you'd be able to say, wait, Miss Pendleton, that's just pi over 2. And so I need to fix all of these. And then we have pi over 2. I'm going to add that. That's 5 pi over 2 and 9 pi over 2. Oops. So hopefully you fix that. And then we're dividing by 3 for each one. So that's going to be pi over 6. And 5 pi over 6 and 9 pi over 6, which is in fact 3 pi over 2. So we would have gotten there eventually, but here we are. That gets us all of our answers from 0 to 2 pi. All right. Now, one more. I have such a good time solving these. 4 cosine squared of 2x equals 2. Then we'll divide by the 4. Then we'll square root. Plus or minus square root 2 over 2. So we had to rationalize at the same time. And then, where does my cosine equal square root 2 over 2? Here, 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 here. So I set 2x equal to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All 4 values that have a denominator of 4. Then we need to add 1 for each. So for this one, I'm going to add 2 pi or 9 pi over 4. So 8 pi over 4 to get 9 pi over 4. Add 8 pi to get 11 pi, 13 pi over 4, and 15 pi over 4. And now I can divide all of these by 2. When you divide by 2, hopefully you've noticed the pattern that we just double the denominator. So we get pi over 8, 3 pi over 8, 5 pi over 8, 7 pi over 8, 9 pi over 8, 11 pi over 8, 13 pi over 8, and 15 pi over 8. So that gets us right up until 2 pi. So that way we get all the answers. The other option that we have is to just try and really find the pattern and then go until we get to 2 pi. But I think the finding the extra angles and dividing by the coefficient is easiest. That's a lot of answers. So if we started with 4 answers, we should have 8 because of the 2. So that's one thing to keep in mind. That will double the amount of answers we have. Okay, now we will do it for all real numbers, which actually is a lot quicker. You think, oh, that's more complicated, but it's actually a lot faster. So it's already isolated. Where does cosine equal 1/2? It's right there and right there. So 2x equals 1/2 at pi over 3 and 5 pi over 3. Now we don't need to be adding on the values because we're solving for all reals, and so our 2 pi in will take care of this. So I'm going to write 2x equals pi over 3 plus 2 pi in, and 2x equals 5 pi over 3 plus 2 pi. And we'll use our same rules as yesterday, where if it's something that can be done in a simpler, less equations way, you need to do that. So pi in if you have diagonals or anything like that. And then divide by the coefficient. So that's going to be pi over 6 plus pi in and 5 pi over 6 plus pi in. It's much easier to do them equations to do for all reals on the complex ones. It's a lot less answers to list out. So we'll do both, just so you can see. We'll start with interval. So 2 sine of 2x equals 1. Sine of 2x equals 1/2. I like a picture. This is when sine is 1/2 and here. So 2x is going to be pi over 6 and 5 pi over 6. For the interval, we have to add our 2 additional answers to get 13 pi over 6 and 17 pi over 6, and then we divide by 2 to get all the answers that are in the interval. So it's going to be pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. And that's it. And then let's see what do we do next? For the all reals, we just take our 2 that we originally had. They're not on diagonal. And so we write 2x equals pi over 6 plus 2 pi n, and 2x equals 5 pi over 6 plus 2 pi n, and then we divide by 2. And then you should see that this will get you the same, like this will cover those other answers. And so we can have these 4 answers for the purple interval, and these 2 equations for the all reals. All right, only 1 or 2 more. So for this one, it's already factored for us. If we had to factor, we would do the same steps we did yesterday. So let's go ahead and set tan of 3x equal to 0 and tan of x minus 1 equal to 0, which means tan of x equals 1. So we'll just do these separately. When tan of x equals 0, tan is y over x. For it to be 0, 0 over plus or minus 1. And so y is 0 here and here. And we'll do for all reals first since I'm doing blue already. And so that means 3x equals 0. Well, actually plus, and we can cover it with pi n, like that. So that will get us it. And then x equals 0 plus pi over 3n. So that's one of the answers. And then for all reals, for the tan of x equal to 1, that means our x and y are the same. So here and here. Also on a diagonal. And so that is at pi over 4. And I can get there with pi n. And so here's my answer for all reals. We have 2 equations that will get us there. And then on the interval, we take our answers that we already had. So we had 3x equals 0, pi. Then I need to keep adding them. 2 pi, 3 pi, 4 pi, 5 pi. And then over here we had pi over 4 and 5 pi over 4, which I don't need to do anything with because it's just x equals, and over here I'll need to divide by the 3. So we have 0, pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, and 5 pi over 3. Those are all of our answers. See how much easier it is to do the ones with the equations? You don't have to list as much out. But I have to say, both are very fun. And that's it. So, hope you guys enjoyed. Thank you for your participation, and check Canvas for what's next. Have a great day.